thank you very much. Today we are going to be doing something in calculus. And what we are going to be doing today is the application of chain rule. Calculus. Application of chain rule. I have seen a lot of lecturers in faculties of engineering. The way they apply chain rule is not the way I wanted them to be. You know, they make it so difficult, and it seems as if chain rule application is the most difficult thing on earth. But today I've come to reduce the difficulties in chain rule. Now look, for example, when you have a simple function, y is equal to x squared, in this case the y ds is you multiply the coefficient of s with the power of x, 2 bracket 2x, then you minus 1 away from the power, 2 minus 1. In this case, we are having 4x. This is your derivative for this simple function. But in case you are having a complex function, for example, y is equal to s squared plus 3x all squared. This equation is a little bit complex, and we cannot just attack them directly the way we have attacked this one. So in this case, we are going to be applying chain rule. And chain rule is this. dy ds is dy du dot du ds. The reason is because if you look very well, you can easily cancel the u and the u out, and at the end of the day, we are going to be getting the y, the x. Okay? So, but the question is, what is the u ds and the y du? So we are going to be working out this equation here, and from this place, you are going to see what I'm going to do. It's like film trick, but it is real, and it is simpler than the way other lecturers are attacking these problems. So look at it very well. Now we have a question. Y is 2s squared plus 3x all squared. The first thing that will come to your mind is this. What am I going to do to make this equation simpler? Now what we're going to be doing is this. We are going to be letting everything in the bracket to be represented by u. Alphabet u. So here we go. In that case, we have y is equal to u. Everything here is represented by u. I think it's better when I write this. Just look. It's better when I write this. Look. Let u equal to 2x squared plus 3x. In this case, the u ds, the u dx is equal to 4x plus 3. The u ds is 4x plus 3. Okay? Now, we are going to go further. Don't forget that we have said u is representing this equation here in the bracket, which means y is equal to u raised to the power 2. Because everything in the bracket is u, and y is equal to u raised to the power of 2. So the y du is equal to 2u. When you differentiate the y du, you will get 2u in this equation. So what we are going to be doing here is this. We are going to be applying our formula for chain rule, and we will be substituting in our figures. Now, the y ds for chain rule, the y ds is the y du dot the u ds. Okay? Now, the y ds is equal to, what is the y du? Now, the y du is 2u dot the u dx. The u ds is 4s plus 3. Now we are going to be recalling something. Recall, that u is 2s squared plus 3x. Recall that u was equals to 2s squared plus 3x. We just record this. Then in this case, we are going to be substituting the value of u into this equation. So dy ds, let me come here. Sorry, I have to quickly clean this away. So in this case, don't forget that dy ds, dy dx is dy du dot du ds. So directly we are going to be substituting in our figures. Now the figures we have is this. Now we have dy ds is equal to, what is dy du? Now dy du is 2u, 2 bracket u. What is u? U was everything in the bracket, 2s squared plus 3x. 2s squared plus 3x times dot represent times du ds, and du ds is 4s plus 3. 4x plus 3. So at this point in time, we are going to be opening the bracket. Now dy ds is equal to, we open this bracket first. We have 4s squared plus 6x. Okay. Bracket 4x plus 3. So we are going to be opening this bracket again for the second term. Now we are going to be using what is in this bracket to multiply what is in the other brackets. So in this case, we're going to be having dy ds is equal to 16x raised to the power of 3 plus 12s squared plus 16 times 4 is 24s squared. 24s squared plus 6x times 3 is 18x. Okay, now in this case we are going to be collecting like terms. I think we have some like terms there. You can look, we have 12x squared here and 24s squared here. So we're going to bring them together. At the end of the day, the y, the x, is equal to 16 s raised to the power of 3 plus 12 plus 24. We have 36. 36 s squared plus 18x. Yeah, this is our derivative. This is our derivative. Now, what I've just considered doing is that when you want to apply chain rule, don't be afraid of it. Just have something in your mind. Chain rule, dy du dot du dx. You make everything in the bracket to represent u, and then you equate everything to what you have just done, or what you have just decided to do. So at the end of the day, this is the chain rule. Chain rule. Don't forget. So anytime you see problem and you have a complex function, and this, what is in the bracket is have a greater power that is bigger than what you can easily open, you just apply your chain rule and that is it. You understand? So I don't have much time because I'm always busy. Now I'm going somewhere right now. When next we meet, we are going to be working with product rule and quotient rule. Product rule and quotient rule are going to be the next things we're going to be doing next time. Okay? Thank you very much for your understanding, and goodbye.
Choose.